All right, welcome everyone. My name's Joe Glines, and I'm here in Dallas, Texas. And me with my colleague Jackie Stuck, who is, I'll let him introduce himself. So quick background: you're here for the AutoHotkey webinar. Today, Jackie's going to be going into some cool stuff he did on optimizing finding images. It was pretty neat. He walked me through it the other day. So, quick background on me: I'm not a programmer, and I don't even dare try to fake being a programmer, but I've been learning object-oriented stuff for, I guess, like 5 years now. It's been a while. I've actually been, and lately I've been getting a bit better and better, but still I'm nothing compared to what a lot of people are good at programming. What I can do is talk, though. So anyway, Jackie and I, we put this together, I think about 2 years ago now, and we just love automating and helping people save time and teaching people how to, be more efficient and work smarter, not harder. Jackie, you want to give them an overview of yourself?
Yeah, I'm Jackie, and again, I'm also an AutoHotkey enthusiast, and I've been working with this for a little over 5 years, and I'm situated in Copenhagen, Denmark, and I've been talking with Joe for maybe three years or something like that. Yep. Yeah, and it's been a great experience, and these webinars are actually quite fun, and just as Joe said the other day, keeping at it just lessens the burden each time. So it's great actually having an opportunity to talk about what we see and what happens with AutoHotkey. So yeah.
Oh look, we just jumped to June here. Sorry. Yeah, and by the way, not just a feature, but we actually put together a Udemy course using hot strings. So let me go over a couple other things. We don't have a huge deck today. Jackie's going to review a lot of his code. I have a little snippet of a tool to demonstrate, but we will email out links to what we share and review, as well as links to the recorded videos of the webinar. So you don't have to try to take crazy notes or anything if you're doing that. Because you'll get a copy, you'll be able to rewatch this later. And let's go ahead and start moving forward here. So there's 72 people registered. Usually we get about a third of that, and then I think a lot of people watch the things later. We all start off muted just because I was on a call the other day, and there were like 3 or 4 people, and boy, the second you get past like 3 people, it's mayhem when everyone's trying to talk and people don't mute, and then the dog in the background's going crazy. So we don't think, Jackie and I aren't saying we're all that. It's just a lot simpler and easier to keep things flowing and clear. So that's why we start off muted. If you have questions, you can raise your hand. There's a little button somewhere in one of the tools, or just jump into the chat, and Jackie and I are always monitoring that, and one of us will, we may not interrupt the other person right away, but we'll get the question out to whoever's talking. And then if it's that complex of a question, if you're up for talking, we'll just unmute you, and just let us know you have a question that you want to be unmuted, and then you can speak. And then that's the first hour. The second hour, and I don't know if we'll take up the full hour this time. We might. It'll be close, I think. But after the first hour, we go through the stuff. Then we open it up for anybody who has any questions, whether it was about what we present today or just stuff you're trying to automate and having problems, and we're happy to try to solve them and work through things or pull up an example of something we've done before. So there are, at least I'd say, like 20-something past webinars now, so you can go check those out. If we might just direct you to some of those depending on your question. But let's go ahead and get going.
Yeah.
All right. So this first one, and I actually just took 2 little snippet pictures of the same tool, but I found this the other day. A lot of you maybe have heard of WindSpy. The original WindSpy program I think it was written by Microsoft, if not someone else, but it does a lot of cool, it does some functionality, but I found this other WindSpy tool written by Alchemist on the forum, and let me pull it up here. And so it works in a very similar way. Same thing as the ACC viewer tool and the IWB2 learner tool, and that there's this little circle target here which you can drag onto a program. Let's just drag it up here, and this is going to update, and it helps you understand the it helps you get information that you'll want to use for scripting, like with AutoHotkey. So you can actually, here I'm on the process. Let's go to the general and look. And I probably should have something else. Let me drag it to a different window here. And you see how it's updating as I'm dragging to it. So this is the class and the class NN. Both of those can be used with AutoHotkey. But it also has, and Jackie was explaining this to me before the webinar, because I hadn't heard of, or at least I don't recall, styles. But apparently styles are a built-in Windows. That'd be the Windows API, Jackie, that you can interact with it?
Oh, I just had a chop in the audio when you actually asked the question.
Of course.
But yeah, something about Windows styles, and would that be the correct something?
Well, yeah, in order to, let's say you wanted to turn off the horizontal scroll bar, you would connect through the Windows API. Is that right? Probably.
Yeah.
Okay.
You could add or remove styles depending on what you are after. Of course, if you want to remove a style, you'll probably need to deliver in a new style number without that style added in. That's the interesting part about styles, is just if you look at these numbers, if you add them together, like if you take the tab stop and the group and you add those, you get 3. But if you take tab stuff and thick frame, you'll get 5. So by adding these together, you can't get the same number unless you actually have that style in there. Yeah,
it's like the message box thing that builds on the different options there that you put in it. Yeah. Okay. So anyway, it was a cool tool. It's on the forum. Like I said, I'll email this out, but you'll have the link to it. I just found it had a lot of interesting stuff in here that the original WindSpy didn't have. And, you've all probably used this tool. Of course, I have a hotkey for launching it. There it is. What was that, WindSpy? No, that's not active window. What was that called, though?
Active window info. Yeah, it was called, I can't remember, Windows Spy or something like that. It was called something like it.
Yeah.
Anyway, but that was an AutoHotkey tool originally.
So, and this has, some of this info will be the same, right? This gives you a lot of different things as well. So just another cool tool for being able to, automate some programs. Alrighty. And then that was the end of my deck, that enormous deck. So now let me stop sharing. And we're going to turn it over to Jackie.
Yeah.
Jackie's going to wow us. No pressure, though.
Wow. No pressure. Let me just see if I can share this. So, yeah.
Yeah, that's good.
I see my screen at the moment. Yeah, that's good. So, not because I've really done anything to prepare for showing all of you this, but the actual thing I wanted to share was a different method of comparing two images to each other. Whereas most of the stuff that I usually do, I would simply take a piece of an image and compare it to maybe with image search or something else like that, to compare two images. And of course, it allows for some variation in each pixel color. And I had a few issues with actually trying to make it a bit more fuzzy in its comparison. And because I was researching how I maybe could get around those very strict only being allowed to actually differentiate on the color of the single pixel, no fuzziness, I looked into doing it some other way. And in my research, I stumbled upon a way of actually getting a percentage difference of an image compared to another image.
Jackie?
Yeah.
Can I just clarify one thing here? Because I just want to make sure, because I'm hearing you say fussiness.
Yeah.
Or are you saying fuzziness? Because the two...
Fuzziness?
Yeah, fuzzy is like, allowing for some random, blurring, where fussy is like a kid that's being annoying, right?
Okay. Yeah, it's it's a blurry comparison.
Okay, thank you. Just wanted to make sure because it could have been fussy, and I'm like it would be acting up, and I'm like I was wanting to make sure I understood, which one.
Yeah, absolutely.
Cool. Sorry.
So yeah, that was the thing. It was because I was maybe that's fine. I was comparing a bit of let's say it was text on buttons to other text on buttons, but each time the program was loaded or if an image was rendered again after being recreated, the actual font on the image had a bit of blurriness to it, so it wasn't actually the same image each time. And AutoHotkey's built-in image search had a very hard time of being consistent. So I had to turn off the allowed variation until it actually got so bad that the variation of it was that if I was looking for white on, let's say, a bit of transparency in the white, so the green kind of got through. So there was a hint of green within the white. So it just didn't work. That's the thing. The variation had to be so spot on. So each time a new rendering version of the image was made, and it didn't work.
And just to clarify, because we don't know everyone's background here, but generally speaking, we've done a lot of other webinars where there are a lot of ways to connect to programs programmatically that are far superior, and I think we can still say superior, right? That Jack and I would both much prefer to do because they're faster, they're more reliable, they're excellent, but of course, if you can't connect to them, then you're like, okay, well, then I'll try this method, then I'll try this method, then I'll try this method. And then you basically resort down to often, like, oh, okay, I need to find an image and detect that image, and then I can click it or I can do something to it. And is that a good summary, Jackie?
Yeah, it simply depends on which program you're trying to do it with. Some programs will, of course, use Windows controls. Others will use other types of controls. Some will use special controls. Most of those, you can actually get to the data that's in them. Mm-hmm. But when, let's say, I don't know, maybe a Delphi program or games or videos and stuff like that, where you can't actually get to the data that's in them, where the only thing you have is the pixel information. That's where the last one of the last resorts, at least, that is doing, let's say, object character recognition or image search to find the button you want to click or whatever it can be, and that was where these issues for me was. It was in trying to actually automate something that where all of what I was seeing on screen was one plain rendered image, and there was no access to the actual information, so only pixel information, and that's where I I had a few issues with actually finding the stuff I needed with the built-in version of image search. Mm-hmm. But to just kind of go into what I actually have here, I wanted to run this small visible part of it here, just to give you a kind of an idea of what actually happens without going into too much first. I'll start by running this. And older instance, yes. So what it first does, it lets me select an image. And right after that, I'll select an image more. You can see it here. So for this, I've selected a few different types of images, put them here. And for this one, I wanted to, let's start with taking the semi-image 2 times. I'll start with this so you can see it's the exact same image. You can see both of them here. Don't think I can make it bigger, so As you saw, I selected the same image file 2 times. It's displayed here. So if I now press compare, it will run the functions that I'm going to show you in a moment. And here I actually got the result of that. It's telling me that percentage-wise, there was 0 difference, and I've added in an algorithm that's checking the lighting. I'd say that's at least one way to say if the lighting, the gray and the white are the same in the image, but we will get into that. There's just to show you that if I compare to similar image, I also get returned that they are
that's mentioning
have no difference.
The difference. Thank you. Yeah, 0 difference.
Yeah, 0 difference exactly. Just to do the same task once more, I'll select these 2 images, and here you have the same images. They are the same size, but as you can see, a bit of the lighting is a little different, and you have a red pen and a black pen, and you have a little piece of text on here. So they're almost the same, but they're still different. But if we compare them, we now get this returned. So if we look at the percentage difference, it is quite high. They have a lot of difference to each other. And if we look at how it's lit, how it's comparable and how the lighting in the image was, they're quite close to each other, which makes a lot of sense. So let's just say okay to that. This was to show you how that kind of works. At the moment, these things up here are comparably simple, using a few GDI plus functions. One here to actually create a pointer to a bitmap of the first file, and a second here to create one of the second. These are then used down here. Yeah.
I was going to say, can you just give a 30-second or 10-second review of what the GDIP library is, if people have never heard of it?
Yeah, I think the GDIP built-in graphic built-in, but I actually believe there are.
Is he cutting out for everybody?
The Windows comes with it from maybe X. Can people hear what I'm saying? My connection is simply choppy.
Yeah, it's a little choppy.
Oh, I'm so sorry about that. Kind of weird. I was just talking about that.
You were saying, did you say it actually came with Windows?
GDI Plus, I have never actually installed it. So to me, it must come with Windows. I've used it on both Windows XP, Windows 7, Windows 8, Windows 10. So I believe that GDI Plus is something that Windows actually comes with, but I'm not absolutely sure.
Okay.
No.
Anyway, it's a library for manipulating images. Is that?
Yeah, it is, of course, something that comes within Windows, and we have some very not old users, that's maybe old-time users that made a standard library usable for us. So by including GDI Plus in your project, you can now access a lot of these graphic capabilities, I'd say.
Okay.
So you can do a lot with images and a lot with graphics. You can, do almost anything that you see on screen.
I was just thinking some people may not have known what it was. And
Yeah, it's fair enough, and just to kind of say that it is a great library, and you can do good amount of stuff with it. What I wanted to do was, now I showed you this, and what I can show you as well, what this is also capable of, is comparing images of different sizes. And I'll just show you here. Let's say I'm missing a button I wanted to have here, but let's go in here. Let's say we have same image, but in 2 different sizes. I'll pick the small one and the bigger one.
The dimensions are the same though, right? The ratio?
Yeah, the ratio of them is the same. It doesn't really need to be the same, but you can't trust the calculations as well if they ain't. For some reason, it didn't actually load those 2 images, perhaps because there are JPEG images. I'm not sure why it actually didn't load them, but for some reason they weren't directly loaded within AutoHotkey's GUI picture control. But
you're cutting out again.
In them, let me just go to the actual folder, just kind of show you.
Yeah, I think we understand though. You're saying
the
they're
images.
Yeah, just different sizes.
The images are different sizes. They are different sizes. One is 730 times 373, and this one is 340 times. So the ratio is the same, but the size of them is different. And the function still returns there's 0 difference.
Right.
But if you look at this one here, it actually catches a little bit, and that's the actual algorithm that's behind the comparison. That's making a little bit of a taint on the actual image.
Interesting.
But still, it's so low. So here you would actually, if we were to time this to actually get it into a percentage, you would get about 1.9% difference, which is like almost nothing. Okay, that was just to show you images of different sizes. And I had also had a few other images, but still. This one where you have 2 that are very different. They're both different sizes and they're different images. I'll just load them in to show you. But again, AutoHotkey's picture control can't load JPEG pictures apparently. But here you can see the difference of them is quite large. And of course, the coloring of the images might still be said to be below 50% difference, but it's this one down here is actually taking the histograms of the images and comparing those to each other. But still, it will tell you how much blue and red and stuff like that that's in the image. But yeah, and if you look at them, yeah, they have about the same amount of darkness and a good amount of blue, both of them, and that's why the last one isn't actually as high as the other one. Actually, the use of these in the end. Let me just reformat some of this here and go over it a bit differently. So if I just start here and select a single image. So what I did now is I'll select a single image. I'll actually get the pointer to the bitmap of the image using the GDI library. And using a function, resize bitmap, it's down here somewhere. I'll just jump to it. Come on. I had believed I would get to it a bit quicker. You can see it here. It's a function that I found on the forum at one point, made by Learning One. And all of what it's actually doing is it's taking the image that it's being fed, and then it's resizing it into a new size, exactly. And the only thing that's different from this function and what he had originally made is that, where did that go? Is this one here, the set pixel offset mode. That's one thing I've changed in this function here. And I've used the one that's 2, and that's the high quality offset mode. And what it's actually doing is when the image is resized, and it's resized down to quite a small size to make the comparison, it's choosing where to take the new pixel information. So when it's shrinking it, the algorithm that's used to shrink it actually needs to know what this pixel here needs to be. So it's comparing the pixels around it, check that it's the side. And here, the offset mode I've chosen is the high quality one. You could have taken the high speed one or the default one, which is a combination of the mode half. Then it would take, let's say, half of this one and half of that one and combine that into this.
You're cutting out again, Jackie. Jackie,
just
there you are.
To let you know what's actually happening.
Hey, Jackie.
So when it does this is the algorithm that I.
Can you hear us? Jackie. Uh-oh. There you are. Oh, you dropped. Hold on. Yeah. There. You back?
Yeah. Okay, I don't know. It dropped me and it reconnected me.
How about maybe it might help. How about you kill your video? Might help a little bit with the bandwidth.
Fair enough. We'll try that. I'll share my screen once more.
Yep.
Yeah, hopefully that will help a little with it. I don't normally have these issues, do I?
No.
Hopefully not. Yeah, it's just a little weird.
So you were, just real quickly, though, you were describing basically how it picks which pixels to basically either combine or from where, something like that?
Yeah, exactly. So when it's actually shrinking it, it's not just taking some random way of doing it. It's actually using a specific algorithm to do it. Not because I actually know their algorithm, but I've chosen a specific version of the algorithm for this use. Okay. And it was the one I was able to find online. That's why I chose that one. Okay. Not because I actually know better than anybody else, but it seems to work quite well, so I'm happy with it at least. So those are those two. So the resizing here is done by the GDI library as well. And Learning One made the function. I modified it a little bit, but not much. Apparently it was needed. It didn't give me that good results with the first one. It resized the images just fine, but somewhere the quality of the resizing was off. Yeah. Maybe because it was just using the default mode, and apparently that's half of whatever is around it compared into one. But yeah. Okay, so after you have resized the image, here I'm resizing it down to a square of 16 by 16 pixels. So it actually takes any size image and makes it into a 16 times 16 pixel representation of the image. So it actually shrinks it quite a lot, down to what, 265 pixels, I'd say, to represent the entire image for this. And because I'm only comparing the likeliness of the images, do you get what I'm saying? I'm not actually comparing the colors of the images. I just want to know if the images are showing the same thing, not if they're showing the same colors per se. Yeah. So by doing this, and then after that grayscaling the image to make the comparison much easier, instead of actually having to compare all of the different color variations by grayscaling it, and let's say setting all of the colors to the same value. That's not the correct way of saying it, but the red, green, and blue will be the same number when you grayscale it. So a pixel will have the same amount of red, gray, and blue. Okay, so you grayscale the image here. Again, this was a function by Tilk, I think, where he had used some kind of color matrix to actually grayscale an image. That's again something I found somewhere on the forum. Here and there you can see his matrix for grayscaling. Again, I'll not be the one to actually tell you if these numbers are correct. I have found these numbers represented in other languages as well. So by that, I'm thinking either he also found them there, or this is just the correct way of doing it.
Right.
I'm not gonna question that, but it works quite well to actually grayscale an image. So get a grayscale version of the image. And as soon as you actually have a resized and grayscaled version of the image, I then have a function here. Here I'll simply call the function that simply goes in and takes all of the pixel information, all of the pixel colors, grabs them and puts them in an AutoHotkey array. So I can more easily loop over all of the pixels in the image. So here I'm taking the fourth pixel over and the fourth pixel down and returning the color of that. Let me just run this once and let's see if it does what I'm hoping it will. So here I'll take this one, open that, and it's saying 52. Okay, 52. What's what's 52? But if I then actually go in here, take the image of the globe here. Let me see if I can't open it with something easy like Paint, maybe. Okay, I couldn't get as close as I actually hoped, but we're still just about there. Again, I had actually thought I would be able
I think we understand though. It's the fourth down and fourth over. Is that right? Something like that.
Yeah, exactly. But I'm totally sure that you actually got it. I just wanted to actually prove that the value of it was 52. But yeah, I don't want to load one of the more heavy programs to actually show you a simple thing like that. But what could I do? I could use this, perhaps. That will give us the information. I need to hit the right one. 0D D1 color. Again, I'd maybe it's better if I just used hex, but still, that's what it's actually doing. It's getting the grayscale version of that color. I can maybe better show it because it's of course not getting it of the entire image. It's kind of foolish of me to kind of try and get you to believe that. Let's put this one here. Grayscale version of one resized image, yeah, and so and so and so. Now I'm just taking this image, resizing it, grayscaling it, grabbing that 1 pixel, but still here doing the exact same thing, but actually now storing the actual image on the disk here. So now here we have a representation of the image that's been resized and grayscaled. And as you can see, it's quite small. It's only 16 by 16 pixels.
Yeah.
But here is what this image over here turns into.
Yeah.
Am I cutting out again?
No, you're good.
No. Okay, I got a alert on screen. So as you can see, it's still kind of there. You get the idea of what this image might have been before this. But yeah, that's actually what's happening here. And if we then take the 4th pixel there, did I still have the WindSpy open? You can see it's 2D, and if I'm not mistaken, that's probably 52. You have a better converter than me, Joe?
No.
No?
Okay. Not to a number like that. Yeah.
Not to a number like that. Okay, then let me just take this.
Well, I think we all believe you.
Yeah, I'm pretty sure that.
But yeah, actually, I'd love to see, because I don't understand. I've never learned anything with colors and how they represent. So
52, right, in decimal, and seen in hex. Okay, that didn't work as I'd hoped. Can I say 2D? Someone is saying something.
2D is 45. Jean.
45, yeah. That's a bit off. I'm not really sure why, what it is. 4 times, yeah, it should be that one. I'm really not sure why it's not returning that one. Maybe, but yeah, I've checked it many times over, and it seems to be correct. But at the moment, that little conversion there might be off. Not exactly sure why.
Yeah.
But yeah, just to kind of show you that. So if we now go, so that was how that worked. And now in the percentage difference here, I'll actually show you the function. That's the one there. Let me see if I can make that a little bigger. This one turned out to be quite big. So what's actually happening is, as soon as you pass in the pointer to the 2 images, again, I'm using pointers here because I'm using GDIP+. You could also pass in, let's say, a path to an image if you want it. Then you'd have to handle it within the function. So at the moment, I'm not doing that. But here, this could instead be actually moved from here into here. And then instead of actually passing in a pointer, you could just path in the path to the file.
Yeah.
There's just 2 ways of doing the same thing. At the moment, I'm just keeping it outside.
All right.
So here, doing the exact same thing, resizing it, grayscaling it, doing it the same thing with the other one. And then using the function to get the differences here. So I'm using get color values. That's the one that's actually storing it in an array. As you can see, first the image, get the dimensions of the image, loop over the width of it, loop over the height of it, and just move through each and every pixel in the actual image. Get the color here. That's just to convert the actual alpha channel out of the actual red, blue, green, and blue. Because if you have the alpha channel there, which the GDI Plus actually uses, you have the amount of transparency in each pixel, as an example. So a completely solid color would be 255 in the alpha channel, and a completely transparent one would be 0. So it's just to remove that because it's unneeded for this. But it makes a lot of sense to have it in different other parts of it. Here it actually just puts everything into a color object, and all of what I'm doing is getting the absolute number of the red color, because it's grayscaled, and the gray, the blue, and the green will all be the same value on each pixel. Just as you saw when I actually took this one, took the WindSpy, each and every of these gray pixels, if you look at them, the color value will be 27, 27, 27. This one over here will be completely white. This one there will be 5B, 5B, 5B. So I have no reason to actually return all of the different aspects of the colors, because they will always be the same as soon as it's been grayscaled. So here, returning the value, like 70 or 727 or whatever the color of that specific pixel is, return that, making sure it's an absolute number, and then just storing it in an array. So, and then return that pixel array. And that's where the, let's say the 52 actually came from. The one we returned last time, that's from within this array here. This is the array that's actually holding those numbers. And this one here, getting that one, it's just, it gets this array down here one time and a second time. And then what it does at the moment, as you can see here, it's looping over the first array. I know that both of these arrays are 16 times 16, so they will always be the same size. So I didn't take the time to actually compare those to each other. Simply just the size of one will be the size of the other, and because it's always square, I don't need to actually figure out the the height of the actual. So and here it's then just taking every last of the pixels from the first array and every last pixel of the second array, and taking those two numbers, the 52 and the 27 as an example, and subtracting one from the other, and storing those in a new array.
All right.
Exactly the same thing. So now I'll get an array returned with the difference between each pixel. So that's what this does here. So here you actually just get an array back with all of the color pixel differences. So that's what this one here holds. And by then looping over the length of that, exactly the same thing, looping over each and every pixel high and low, and comparing them to this little thing here, a small threshold, I think, threshold. And here you actually, if you didn't know and you didn't see it earlier, the algorithm, the one that's used, the high quality one, still isn't completely perfect. So it still makes a little mistake or difference in the actual compressioning of the image. So even though it's using the algorithm that's high quality, compressing the same image 2 times or resizing it down 2 times will sometimes result in a small, very, very small difference in the final color. And that might be what we saw earlier with the 47 and or the 45 and the 52. Just that could be a thing there. But this threshold of 3 is what I have found to be very, very, very reliable. It's only making mistakes that are smaller than that, at least to what I'm seeing.
On that one, what are the other options? I mean, what is 3 compared to?
This is just if you, let's say you have a very simple color, like one of these here or whatever it might be. When it compresses this area down here, the first time it does it, it might end up with saying that it's the color 52, but the second time it compresses it with the second image, it might say that it's the color 51. Just because the algorithm that is doing this is making a little bit different assumptions the second time around, or the rounding is a little different or whatever it is. But at least to me, it seemed like it had a small amount of mistakes or whatever you would call it.
I'm just asking those 3 is like, might you have set that to 4? Would that change it? Is that better? I don't understand.
Yeah, if you let's say if I just to kind of explain it, I'll remove some of this up here and run this once more, like so, like so. Oh, that's the wrong key. Like that, and like so. Okay, and with the message box there. So let's say I'm now running it with the default of 3 on this globe here. And of course that didn't work. I'll take a different image, one that I know it can actually show. So I'm picking the exact same image, so I know that it's the same image. And I'm comparing it, and it's returning the zeros here. And it's doing that on with the threshold here of 3. If I now set, just to make it really interesting, let's put it a bit higher in threshold, 10. Now, running the exact same thing, I'll be almost certain that I'm getting zeros. Now, so now it has a variation allowance, a threshold of variation of 10 instead of 3.
Okay. If you'd put it to 1, it may not have come back as the same, possibly could not have come back at the same one.
Yeah, exactly. Let's see if we put it at 1 and do the same thing, even though it's, we know it's the exact same image, so it should return a 0. And it still is, so that's good. But again, on some images, I experienced when I didn't have the threshold here, that it would make a small differentiation, even though I knew that the image was the same. So putting it at 3, I eliminated all of the cases that I had, at least, where that was an issue. So, and if you look here, all of what it's actually doing is looping over the differences, comparing them to the threshold. So if the difference between 2 pixel colors are more than 3, it will add it into the actual percentage number. So
Okay, that makes sense now.
Doing. Yeah, so that was the idea of the threshold here.
Thank you.
And I actually believe that I got through what this does. Does that make sense to you? Am I missing a lot?
No,
I know that I didn't go into this one here. I actually Googled what this is, and this guy here.
Yeah.
He actually says the name here.
We can't hear it.
Lord, yeah, he's saying the name Lord Bhattacharya, and I still can't pronounce it, but I just wanted to actually know what that, and it was an algorithm that I found online.
Cool.
And I built it, and you can just see it here. It's again, it sounds quite wow, but all of what it's actually doing is comparing the normalized histograms of the same images. So instead of actually comparing the pixel by pixel thing, it's just comparing the colors. So how much red, how much of each pixel. So it's, again, here you can see it's looping over the third array, the fourth array, and again, this is just the names that I've given them, and adding them together in different ways, and then it's looping over it one more time to see if there was a difference between them, and then at the end it's returning that as a percentage number. So just to show you that this one here was kind of an extra thing. I was trying to prove to myself that this actually worked. Do you get what I'm saying?
Yeah.
Taking someone else's work and trying to compare it to what I've made myself. So yeah. Higher threshold is the other way around.
More tolerant.
A lower,
you'd say, yeah.
Yeah. It's more tolerant, yeah. So yeah, that's actually how that works. So what you can do with it, or what I'm using it for, is
let's get to the cool stuff, because this was, it blew my mind. Like what you showed me, I'm like, it's really comparing those two things, and
yeah. One of the things that at least I'm using it for is when I distribute things. This can actually help me quite a lot, because when I have images that I want to compare, let me just move this line here again, down here. Okay, so what I can do is I can, of course, have the full-size image and compare that to another full-size image, and that will work just fine, and I will get the differences between those. And at the moment, it's giving quite a high percentage difference, but not that high of an Bhattacharya difference. But now, as I actually stored the resized grayscaled version of the large image, I can, instead of actually comparing this image to that image, I can now compare this image, the small grayscaled version, to any of these two. So I'll just show you. So if I, instead of picking this one, actually pick the small one, this one I could have stored somewhere in a Dell, or just a folder filled with these. I'll compare that one to this one, just to make the same comparison as before. And it's only showing one. But if you look here, the numbers are almost exactly the same as they were just a moment ago. So the percentage difference between the very small grayscaled version of the original image and the colored large-sized one is very, very similar. So instead of actually storing large image files and distributing those to people, I can instead store these very small 16 times 16 grayscale versions that are way smaller and still compare them to screenshots or whatever.
Why don't you, just because it's easy, you have that folder open, right? Show us the file size of those two files, right? Because I noticed the one was like 911K, I think, the small one.
So let me just take this here. So this one here is, again, not a big image, but 158 kilobytes.
Mm-hmm.
And the small one is 911 bytes. So compared to each other, there's quite a lot of difference. And of course, if you did it with a larger image, let's say if you did it with the globe one, or if you went all out and took an actual larger image.
Yeah.
I don't know if I have one that's actually really, all of these are, of course, great. No, none of these are really heavy hitters when it comes to images. Maybe I have something myself. I wanted to scroll, come on. No, don't know. What do we have here? I probably have something somewhere. But, large.
And correct me if I'm wrong, the built-in like image search would really have broken on those, right? Especially when you shrink it down.
Yeah, it has some kind of scaling that you can do, but I've never really, perhaps I haven't tested it enough, but I've at least not found it. And the real interesting thing for me is that images that have very, very subtle differences are not really something that hits hard with these methods. Do you get what I'm saying? If I actually want to compare something that only has things that are different naked to the human eye, so you wouldn't actually see it as different, but the computer would see it as very different because the pixels are just slightly off. Well, we wouldn't be able to actually see that.
Let's do an example, because you have that red and the blue pen, right? Let's shrink both of those and then compare those two small ones.
Yeah.
Right? Is that a good example on this? Because
it could probably be fine.
Because I don't think I could tell those apart when they're small.
No. Let's say it will, at the moment I've only set it up to actually store the first picked one, so we'll just pick that one 2 times. And okay, I need to just go over here, or there, in here, and rename this one. Why can't I rename it? Okay, I needed to hit it better. Just give it a 1 or something. It will just override it if I didn't do that. So there you have these two. So you have this one, which is the new one, which is the one with the red pen. And you have, I'm just showing them, not because we might be able to see the difference, but just to show them.
Right.
And this one here.
Yeah.
So we might be able to see a little bit of some of the differences, but not too much, but it's there. But when we do this and compare let's just take the one without the red pen and compare it to the one with the red pen and compare. As you can see here, you're still getting the differences. It's still a little bit off where it was before because it was 0.6, but now it's 0.58. But still, it's very, very close to actually hitting it right on the nail. So, and if I, let's say, ran this once more and took this one, this is the one with the red pen,
Yep.
and compare that to the one with the red pen, and compare.
Wow.
See, the difference of those are,
that's crazy.
Yeah, it's working quite well, and of course there's a little bit of the color difference, but here you don't have the threshold on this one. The Pachicharya difference doesn't have the threshold that I built into the other one. So that's kind of what you're seeing there. So yeah, that's kind of what I wanted to show. Of course, this could be used in a multitude of ways. You could use it to maybe look up other images or compare one image to a folder of other images, or and still without actually knowing the sizes of the images and stuff like that, you'd still be able to compare them to each other in a quite quick way. I've never benchmarked this method, but to me it just blinks up, so it feels quite quick.
Yeah.
But again, if you needed to compare 1,000 images, it might take a moment. But again, what it's actually doing isn't that heavy. It's when you don't sleep in AutoHotkey, and if you, let's say, set batch lines -1 or whatever you want to do, looping over and storing values in variables, maybe making some very, very simple comparisons here. I can't see this actually taking that much. The only thing is I probably have some overheat with storing the same array in different variables a couple of times and stuff like that.
Yeah.
I don't think I have too much of it, so.
Cool. Hey, it sounds like you're at a good spot to stop the recording.
Sure.
Cool. All right, let's go ahead and stop it real quick.